Yep, rockets can fly in a vacuum. Let's unpack that. This has got to be one of the most common questions I see asked both in the comment section in my videos and around the internet. How can a rocket fly in a vacuum? Now, it comes from the misconception that a rocket launches off the Earth because it's pushing off the ground, and that it flies into orbit because it's pushing off the air to get there. It's easy to see where this misconception was born, because most of us interact with a car, or specifically a car engine, in our daily lives. A car can drive because of its combustion engine. A small amount of gasoline is added to air that enters your engine as you drive down the road. That air and gasoline mixture is compressed and then ignited with a spark. The force of the gas exploding because it's compressed and it lit with that spark forces exhaust out the back of the car. We have forward momentum because we're also using the friction of the ground. Depending on what gear it's in, the car moves forward because the wheels turn. So let's take this car engine as an example. We know that for something to burn, we need a fuel and a spark and a source of oxygen. We have that fuel, it's gasoline, we have oxygen from the air, and we have that fire, we have the spark in the engine. But we also have movement because of friction on the ground. Now, this is where people think rockets fly by pushing against something the same way a car pushes against the asphalt. But rockets don't work the same way. Instead, rockets harness the power of Newton's third law, which states that for every action, there is an equal and opposite reaction. The force of the exhaust leaving your car does push it forward, only the car is so heavy and there is so much friction from it sitting on the road that it doesn't actually do anything. Not to mention, we have things called brakes that stop the wheels from turning. But a rocket has a lot more fuel and a lot more combustion happening, so the reaction is strong enough to lift it by virtue of Newton's third law. Let's use this balloon as an analogy. So with the car, we have the force of the exhaust leaving the back of the car, but it's so heavy and there's so much friction against the asphalt that it doesn't move. So it's the same way if I release a tiny bit of the air but hold the balloon steady. There's air escaping it, but it's not moving. So let's now say that this balloon is a rocket. This is the body wherein all of the combustion is happening because it's just fuel tanks and oxygen tanks. And this is the engine bell, where all of the thrust is going to escape the rocket. Now, with nothing keeping it down, with absolutely no friction on it, granted there is air friction, but it's pretty minimal for the purposes that we're talking about right now. If I release this balloon, the force of the gas escaping will propel it forward, exactly how it happens in a rocket. Should we try it? That's exactly how a rocket flies. It's just that force of the gas escaping from the end of it that propels it forward. So that's part of it, but if you remember from our car analogy, the car needs air to burn that gasoline, and it gets that air as you drive down the highway. That's because we have air all around us. Really, it's burning the oxygen. And of course, there's no oxygen in space, and there's less oxygen as you get closer and closer to orbit. So how can a rocket possibly work in space? Well, there are tanks inside a rocket that have both of the elements you need to start combustion. There's always a fuel tank or a propellant tank and an oxygen tank or some kind of oxidizer. Take the Saturn V for an example. It burned a mix of rocket-grade kerosene and liquid oxygen. This meant that no matter how high it got, it could always have that strong reaction because it had everything it needed to start that reaction and maintain it on board. A rocket that fires in a vacuum does the exact same thing. It has both the fuel and the oxidizer on board that it needs to burn. Of course, it doesn't have to be kerosene and liquid oxygen. There are different mixes of propellant and oxidizer that lead to the same reaction that allow a rocket to fly in space. But then there's one more thing I should mention, which is different kinds of propulsion, because I can hear you guys asking me about things like ion engines. Well, ion engines harness the exact same rule, that for every action there is an equal and opposite reaction. In an ion engine, a gas like xenon usually is ionized. This sends a stream of positively charged ions shooting out the back of the engine. It's a very small amount of thrust, but it's enough to gently propel that spacecraft on its way in a vacuum. So every kind of rocket we've ever used, whether it's chemical, be it liquid or solid propellants, or some kind of electric engine like ion propulsion, it all comes down to the force of the gas or ions or something leaving the end of that rocket, propelling the spacecraft or the payload or whatever it is forward with the same force. And I imagine that you guys still have questions about this, so leave them all in the comments below, as well as anything else you'd like to see covered in future episodes. And I want to remind you guys that if you like this video, you can now sponsor Vintage Space and help make sure that I can keep making the content that you love. As always, be sure to subscribe for more videos and also follow me all across social media for daily Vintage Space content. You can find me on Twitter, Instagram, and of course on Facebook. As always, guys, thank you so much for watching.